Hello, everyone, and welcome back to the second edition of CLEAP Security Conference, CLEAPCon 2022. We started the conference in 2021 to raise awareness about cybersecurity in the world, and we have been conducting a lot of webinars, conferences, podcasts to cover all novel and new topics under the security domain. And since that time, it has annually brought together leaders from industry, government, academics, and security researchers. And today, with the last and final talk of our conference, we have Nishant, our very own consultant with Cleap Technologies, joining in today. So, Pooja, over to you.
Thank you, Shivani. Thank you, everyone, whoever is watching at us now. It's already late, and especially on the weekend. So, we are incredibly excited to have our last speaker, my colleague Nishant Shekhar Singh, as one of our workshop session speaker. And he is working with us as an information security consultant. And he is a university IT graduate with cybersecurity background and possesses expertise in cloud safety, automation, and digital forensics, and he plays an active part in building a community around ClipCon. So please welcome Nishant Shekhar Singh.
Thank you, Pooja ma'am. Thank you, Shivani ma'am. Uh, I will get started with the presentation. If I have the okay. So today's my session will be on introduction to Android pen testing. My name is Nishant. I've been working with Cleap for past 1 year as a information security consultant. Uh, if in this session you have any questions, you can contact me in my LinkedIn ID. Today's agenda will be that we will go through introduction to the pen testing, and in this we're going to cover the Android internals, the architecture of Android, and a live demo, because I believe security session should be live, and I can explain that much better. So let's talk about Android internals. So basically, what internals means, what is made of, and how it progress, and what it consists. So Android is made of uh, Linux kernel, and because it's Linux, that's why it's open source, and that's why it's very useful as well as very vulnerable to any malware attack. That's why most of the malware attacks on a mobile applications happens on Android, because it's very easy. It's open source, very easy to understand, but it's not that it can't be secured. Uh, it's also the application actually runs on Delvic VM. We will discuss about Delvic and other things in later slides. Uh, APK file actually is a zip of files consisting resources, signatures, class DEX, and Android manifest file. So all these the combination for all these files actually makes an APK file. Uh, every one of these file actually have a very useful purpose, and without these files, APK will not exist. So that's the whole concept of having so many different type of files in an APK. Let's talk about one of those files, which is manifest XML. It's an important file. Like I said, it uh, it uh, it is in the Android package. The specific properties of the application is actually in the XML file. We will talk about the properties and how the Android application functions later. All the permissions that have been given to the application by you when you install an application, you have to give the permission. Those permissions are actually listed in the XML file, and uh, the best the most why it's an important file, because it can't be altered later. If you try to add that file later or try to manipulate that file, The application will give you an error that the application has been broken, or it can't install in the system, or can't run in the system. So that's why it's a very important file. I will talk about a little bit about how application develops. So first, a developer writes a source code, and source code which is in Java. So Java is a well-known language. Then the code goes to the compiler. Then it becomes a bytecode. Then it goes to a DX compiler. So DX basically uh, change the whole Java to DX, but the code is still in Java. So DX actually makes it multi-platform runner. So it can actually run on your PC in an emulator, or like in a sandbox environment, and then also in your phones and other Android platforms. So that's why it's needed. Then it gets converted into a Delvic code, bytecode. That's how what I said in Delvic VM, how Delvic VM works. That it's basically a platform that runs Java code in a DX format, and that's how it's different from web application, Java web applications, and uh, how it's different from Java application and the Android application. Uh, After that, it's basically zipped all the files into an APK and becomes an APK. So that's how the cycle works, application cycle works. Uh, Components of the application. That's what I said. That's why manifest file is important, because the manifest file actually consists all these applications. First of all is broadcast receiver. Uh, it's very simple to understand what broadcast receiver is. It's like if you have an pop-up on your phone that says uh, you have a message from this, or you're somebody trying to have a permission without you opening a application. All those pops are basically run by broadcast receivers. It's a Android function, contains many things. Then comes the activity part. What activities are simple, how your application runs on every stage, how every count of the application is run on the activities. Then there are services. Services are what you provide. In the manifest file, it's written that this service will be needed, like HTTP, HTTPS. These are all services, and that's how your application actually works on services. Then are content providers, which are basically a very important part, in which the application actually asks the system, uh, the kernel, to permit it to uh, like use another application for resources, or use the temporary folder or the storage and everything. So all those permissions that you don't actually see happening on the phone every time, it's because of the content providers. And there are some additional components also that we don't have to get into details, because we are not actually developing an Android application here. Uh, I'll move forward. Yeah, I will move forward to the demo. Uh, okay. So today I will share my whole screen. So let's share the screen. I think so you will see our faces also twice. So sorry for that. Okay. So how the testing actually works in Android is that first of all, uh, what we are going to use is a sandbox application, in which uh, there will be many vulnerabilities that are listed in this application that we will cover one by one. Not all of them, because there are many, and we don't, and some of them are very repetitive. So I think so if the simple idea, you will get the simple idea of how it works, and then we can go forward with the other issue of the application. So what you need to run an Android application pen testing is first of all a sandbox environment like this. This is a menu application. You will find it. It's a stable application also, so you can run your emulator here, and it will help you in testing. So you can install your. It works like a phone, but it's on the PC, so it's very easily connected and easily accessible. And you will need another platform. I'm using Kali here to testing. You can use any other platform as you wish, but Kali provides many tools that help in Android testing. So we're going to use Kali here. So we'll start with the pen testing, and in the testing, I will explain many things that will help you understand how actually you can harden the security and test if there is a security flaw. I will refer to my notes here. Sorry for that. Okay. So first of all, the simplest way to test the phone is to actually connect it to ADB. ADB is basically a bridge between the application and your testing environment, and it actually shows how is there any application any Android application that has been connected to the system, and we can have the information from there. That's why I said, because it's on a Linux kernel, it's very easy to fetch the data from the Android kernel. Because it's open, you have no restriction on that. So that's why you have to harden the security much more in this than iOS or any other uh, Android mobile platforms. So first, what we'll do is we will try to connect this phone with my Kali, and for that you need, simple thing you need is an IP address. So the IP address is 192 and 168, and to connect to this is the IP address, and I will try to connect it with ADB command. So I have already have the IP here and try to connect it. So it's showing already connected. It will show you it's connected because I have already been connected to this sandbox environment. So it will show it like this. So what we're going to do is we're going to use ADB now to test the first vulnerability. So what we're going to do is it's showing insecure login. So insecure logging means that whatever you're doing in the system, we will log in your phone. So it's a basic logging mechanism that is present in every application and every phone. So that if there any problem with the phone itself will go to that log, try to refer to the log and try to solve it. That's the purpose of it. How the hacker or anybody malicious trying to use it will, because it logs everything, it will log every activity that is going on in the phone also. So to show you how it works is I will just write a simple command adb logcat. So basically cat is used to print it, uh, and log is basically what logs means. So if I press enter to it, you see the bottom. So what you see here is every click, every activity, whatever I'm trying to do, will be actually be shown here. So if I go back and try to open the application one more time, so everything will be written here in blank letters. So that's how logging works, and this happens with every application. Right now, it's actually not vulnerable. You might feel like it's vulnerable, but it's not vulnerable. How it becomes vulnerable if you try to enter a sensitive data like your card information. And if I try, if I enter one, if I enter 1, 2, 3, 4, 5 and check out, if you see here, uh, the card information actually been logged and shown on Logcat. What will happen in this scenario if thing like somebody have the access to your phone and uh, enable debugging in it and try and connect it to so the user of the phone user will never know that it's connected and it's been hampered from outside. Uh, so what the person, if it person try to enter the credit card information here and the person have logged enable. So that person can see the credit card number and try to use this information forward to actually harm you financially and try to gain more access from it and many more things. So what is happening here should not actually should be done here. So this is the first thing that any ethical hacker also checks for logs like this, because if this is happening, it actually opens a window for many more exploitations, because this is very basic vulnerability that actually doesn't happen with any application, because it's a vulnerable application is actually showing something like this. So this is what happens when there are insecure logging. I will move forward to another vulnerability, that is hard coding issues. Now hard coding issues, I will close this log, clear the data. So there's hard coding issues. So what hard coding issue means, that the developer actually, while developing, by error or by basic neglect, they actually write uh, very sensitive data in the code, because the code is I will show you how you can access the code. Because the code is visible to you very easily, and uh, it happens in Java code, that Java code is very much understandable, and it's not very uh, hard to dissect. Even though you don't have much information about the language, you can actually see stuff and read stuff because it's plain English. So person can actually gain sensitive information about the application that should not be there. That's how you recognize a hard coding issue. So why it's called hard coding? Because it's been written there by the developer. It's not a pre-reference, it's not pre-coded, it's not like this. It's written by the developer. That's why it's hard coded. So how you can access the source file? It's very simple. In the Kali, there is a application called JDX, uh, JDX, sorry. And when you open the application, it will ask you which application you want to see. So I will select Diva and open it. So it will take a little bit of time. And now you can see the source code of the application. And if you can see the source code of the application, uh, you can just go on this. This feels like an important folder, so I will open this. And then I will see there are many classes here. So basically, because this is Java, so these will be basically classes. So what classes is a very simple uh, application terminology, that because Java is an object-oriented programming. So every object need a class to have their contained data. So, and that's how an application has been built in Java application. How Java application works is there are many classes connected to each other, and that's how the application actually works. So is there, if there are classes here, I will check for hard coding issue part 1. So if I can see the hard coding issue part 1 here, okay. Hard coding activity. I think so. Activity, like we discussed, activities are very important. So here classes are actually working as activities. So I will open the hard coding activity here. Now I can see the code here, and uh, if you notice, there's something written here is vendor secret code, and it's actually here, it's actually asking a vendor key. So what I will do is I will just try to, I will, it's very useful to, even if you try to copy it and paste it, it will actually help you, because uh, if you try to access it, I think so, the message was blocked by the images. Okay, so you can see access granted, see you on the side. That means it actually worked. So from this we can understand, if a developer actually wrote this for the ease of it, to if they forget the password and they want the recover the password, they can just see the code. But in Android application, it's very bad practice to do, because everybody can see the Android code, and that's how you actually go for the hard coding issues. So how you actually go for hard coding issues are very simple. uh, you will not have hints like this. You will not even, like, it's in very plain environment here, will not be written like this also in the application that we are going to test. So how you can find hard coding issues are very simple, that you have to actually see the code, and whenever there is hard coding issues, always going to be written in uh, quotations. And because it's hard coded, it's written by the developer, uh, quotation actually means it's written by the developer, and you only have to see the quotations. And you, whenever you see something like this, that you have to actually note it down, keep it in your keep it with yourself, and use it whenever you find a very specific location like this. Another way is to just go through one of the activities. If you go to one activity and you, like, you opened a page and there is a login page, go to that login page activity, see that code, and if you find anything suspicious, note it down, try to do it. So it actually opens a big window of vulnerabilities, that if there is hard code issue present here. Now I will move forward. I will close this, open my terminal. uh, Now we will move to, let me see which will be uh, easier for me to end in a short file. Um, yeah, let's go with insecure data storage part 2. So it will actually cover two topics, and it will very easy for you to understand. So insecure data storage, like hard coding issues, insecure data storage is very similar, but very different also. So what happens in insecure data storage? Because you have the access to the application, that means you can actually decompile the application also. What decompiling means, it's basically reverse engineering. So because like we discussed, there are many files in Android application. You can actually see all those files in your in the system if you connect by ADB. I will show you how, and by that you can actually see the content of the application also. So if you can see the content of the application, and the developer actually have an error here, like like this data, this is a very insecure data. You actually have to third party name, third party password. So password is a very sensitive data, and whenever there is a sensitive data involved, you actually have to see like if this data has been stored in your system. When I say system, I mean the phone. So how you can see it? It's very simple. I will go to the same process one more time. I'll go to the code. So because it actually the sensitive actually most of the sensitive information is in the code only. So I will go to the insecure data storage 2 activity, because it's the second part. Uh, what I see here actually is some sort of query. So what do I believe? It can be SQL, because SQL is a very common used database, and it's very lightweight also. So I can characterize it by the query also. It can be SQL. So one thing I know, that this information is actually being stored in SQL type. So what I will do is I will just type something here, like I will type password as a username, and password, I don't know what did I type, but it's there. Okay, so it shows third party credentials have been saved. Now what I will do is, because this has been stored in your system, so, and I'm connected to the phone also by ADB. So what I will do is I will just try to find that data in the phone because it's already here. So what I will do is I will type a simple command called adb to check if you are still connected. You can check it by devices. So yes, I am already listed. So I will type adb shell. So what adb shell will do is it actually opens a phantom terminal for your phone. So now you're connected to the phone, and whatever commands you will type, that will actually reflect in the code. Like I said, it's also Linux, so all the Linux command will still work. Like to some extent, not all the Linux command, but for some extent, it will actually work. So what you can do is now if I'm here, let's see where am I actually. So I will type ls. It's look like a it's look like an open directory. So what is useful to me is the data part. So like every information of every application in the phone is stored into a data folder, which you can see here. So what I will do is I will type a cd command, which will open this data, and let's see what is here. So it looks like there are many applications, there are many folders here. But the useful thing maybe, I think so, we have to dig a little more deeper into the data part. So what I will do is I will go for data one more time. Now, if I see, now I can see some sort of application folder. So it actually consists all the applications, whatever you have in the phone. So what you can do is now, if you like, I should have discussed this, how you can recognize the name of the application. But if you do a little research, you can find out how to, and if actually reflects on the surface also, sometimes it doesn't reflect. Like in this case, is actually a little hard to recognize which folder it is. So what I will do is, yeah, so it actually shows the diva word here. So if you search for it, you will find diva. I think so it's somewhere here only. Yeah. So you can see the name of the developer and the application diva. So what I will do is I will press enter. Now uh, I am in the actually inside that folder. Now let's see ls here. So there are three, four folders here. What is useful to us, like what we discuss, because SQL is a database, and we see a folder something like database here. So what we will do is we'll go inside database. So let's go inside database and see what is there. So there are many things, many databases and folders, and I don't know what sort of permission they have. If you want to check, you can check permission by this command. So these looks like some read write permissions here. So how will I recognize uh, which folder or which file I actually have to open? So then you actually go back to the code only, and every time, like 90% of the time, if you going through the application like this, which actually have vulnerabilities here, it will give you hints for you not to differ from the path. So this simple hint is right here. So on this line, I can see ID2 written here in quotations. And like I said, whenever this is written in quotation, that means it's written by the developer. So if this nomenclature has been used, I think so I can find the same information here as well. So there is an application here. So I don't know uh, which type of file this is. So the simple command is to cat it. So like I will try to cat it, and it actually opens up, and it actually shows you the data which we entered here. So if you can see, I wrote password as a username, and uh, password or some sort of password is written here. So if you can see, if I highlight it, you can see everything is in plain text. It should not be in plain text for one reason only, because it's sensitive data. It should not be shown here. And that's how you recognize insecure data storage. So this has been, it might look very secure because it's very inside the system, but a hacker will not stop at a beginning of like, oh, there's 3 database, 4 databases. How will I recognize it? So he will search for more hints, and like how I search for, I found this database and I found this in plain text. And this is very openly written here, and this is not something that will uh, be like it's a code or something. So it's written here and it shows it very perfectly. One more thing you can do is whenever you uh, come across SQL. So I catted it. I actually thought that it will not open up, but it did open up. So how you can actually open a SQL file is very simple. There is a code called SQL lit 3. So what it will do is, okay, I think so I wrote it wrong. It's SQL lit 3. So it's properly for SQL only to open SQL files. Now I will type to okay, so it's not actually in the system. That I think so. In the phone, you actually have to install SQLite 3 for it to run here, I believe. So, but Cat actually did our work. Cat actually showed us how it works. But if you actually have SQLite and you want to actually see the data more clearly in a more table-like manner, like how SQL is, if you know how SQL works, then you will understand how table works and how data is queued. So it will show you in a very practical manner. And if there is more passwords and more information stored in here, so the table format will show you better representation. So it actually works, but I think so. My emulator doesn't have that uh, feature in it right now. So this was the insecure data storage. There are many other type of insecure data storage also, uh, but all these are very common. All these are going across the code and understanding where it's been planted or it's been stored in a temporary file. The process is actually very similar for insecure data. You have to recognize the code and then move forward with it. And then you only have to understand how to link whatever the information you have found in the code to an application level. So you can see the code and see the source here. So I will move forward. I will see which one will be a different application for us to understand and to have a new challenge. So I will go for input validation issue. So when how input validation works, like if you try to enter something and like a password, every application nowadays have username and password in it, and if there is a username password, I think so before the sign up process there is a login process, and for login process the phone actually uses the internal database only to store the login if it's not listed on the cloud, if they're not using any APIs here. So they will be actually listed in the phone only, so all the data will be stored in the phone. And how will you know that the data is stored in the phone? You can see how heavy the application is. Even the lighter applications also always stores their little bit of sensitive information in the phone, so it actually rendered fast. So the user don't have to sit there. The cloud will work and then we'll log in. So some in the cache memory, but never in hard memory. So what we're going to check is input validation. So it's showing search, basically search. So it's basically to search something. But why, if there is any input field, and this is very common in ethical hacking and in hacking, that whenever you see an input field, you will try to run a simple query here that actually extremes the data and reveals more data than it should. And it's very simple. And whenever you see SQL, every hacker's just eyes just light up and want to write one simple code here, and it will actually reveal many data. So I will do the same thing. So what I will do is I will type this command, which is I think so. It actually varies with many. I'm writing this. You might have to test it. There are many always true statement. This is a always true statement. So what happens here that uh, because I believe like we saw earlier, it's actually running SQL 3. Uh, so this is a SQL 3 always true statement. So how these statement actually works is a long process, but I will try to explain it in a short form. What you do is try to end the written query and write your own query. And if the permission and the system, the application is not that on rate limiting and stuff, so what it will run your query, not the query it's actually written in the code. So if I go to the code, it will explain you much better. I'll go to input validation. If I can see input validation here, it's 2, this is 1, injection. Uh, I think so. This is the one. Yeah. So you can see the code here. So SQL, wait, I have to see input validation. This is part 1, right? Um, okay, let's take this for the example only. So these are all written password here. There are also sensitive data exposure here, but we'll not have to actually think about sensitive data exposure. What you have to actually think about is the query here. So what will happen if I try to maximize it? This is actually not helping. Yeah. So there is a query here. Create table. If not exists, SQL user. This. What will happen if you try to enter this always true statement? Uh, I think this was it. No, this what or one always equal. I believe this was the one. This will work in this. Uh, I believe yes. I have to take space here. I have to take space here. Yes. So what will happen? This quotation will actually end the statement, and after that, the statement will run or this is equal to 1. So this is a always true statement, and it will show all the information that is true for this search bar. So if I click here, I don't know what happened, why it's not working. Am I writing the right code? It's showing a space here. Okay. This is happening for the second time with me, that I'm stuck on a page. Try to do it one more time. If not, I will move forward and okay, it's actually not working. Okay, so what will happen when you put an always true statement like this and you click search? What will happen? There will be a prompt that will actually show you uh, this information. Uh, Admin password, this, Diva, John, this, as a prompt. And whenever you see something like this, it actually reveals more data than it should do. So there are two things here actually exposing too much data. and because it's happening because of the input validation part. So uh, that's how it actually works. It should work here also. I think so. There's a problem with the code here. Most probably, they have changed it this permission statement to
They're
something
using
else.
single equal, Prashant. You're using equals twice.
Oh, no, no, no. It's double equal to okay. Okay, doesn't matter. Doesn't matter. Okay, now we'll move to uh, let's move to access control issues. That's a very interesting part, access control. So how it works, how access control issues works is basically in the manifest file, there are many things that are listed here, so you can understand how it works for the user and for the developer as well. And so like every application, web application also consists APIs. These application also consist APIs. So how you recognize which API they are using? It's very simple. You can just use logcat and see which APIs is all which activity is actually working when you open the API. Yeah. So I will go. I will just see if it's the shortest one here. I believe it is. Okay. So what I will do is I will actually exit from here if it works. Yes. And I will go to logcat one more time. So I will enable logcat and open the access control issue one. If I open it, what I see is access control issue activity is the first thing that is run. So what what happens what happens is these activity should not be accessed outside of the phone. When I say outside of the phone, that means when how it works is I clicked on the icon and then the application actually opened. It should not open by any other means. But what happens in sub application, it happens with me testing when I'm working, and we found in many like in application these vulnerability actually exist, and people don't actually recognize it because it's because in the manifest file they think it will help them make their application lightweight or very easily accessible and stuff like that, but it actually makes it vulnerable because if the attacker actually opens something that it should not open, it will actually open up very like an application will be open up and the user will think this application is actually uh, buggy or something is happening with the application. So what that person will do is uninstall the application, and if it started working, it will uninstall the application, and they will submit this report that this application is buggy, but it's actually not buggy. It's because it's done by the attacker only. So how it works is it's very simple. When I clicked on it, I see access control activity, something like this. It's running here, and start U0, something like this. This is activity manager. It's actually showing. So what activity manager is? Uh, it's a manager in your Android phone that actually manage the activities of every application that runs on your system. So whenever you see a something like this, that means an activity has been pushed to run, and you will see many times you will see activity manager here also, and in every case you will see activity manager, access control, and like it's very common for this, and it's not actually vulnerable. It actually reveals data, but it's not vulnerable. It becomes vulnerable when this activity you can open it by another system. Like I will try to open it from here, from my Kali. So the process is very simple. I click here, then this page opens, and I can see this. When I click on it, I view API credentials. I see API credentials here. So let's go to logcat one more time and let's have a clearer look what we have to do. So when I click here, there's another activity called activity manager, something like this. This is this. Okay, cred. Okay, API cred activity has been started. That means when I went here and opened this actually started. How access control will work is I will not click on this, not click on this, but it will directly open this page. That's what I'm trying to do because how you can see it in like an application getting logged, open the log like the home page without even putting the logs. That's how you can see in a practical way that how you application use. So if I don't click here and click here to log in and see this information, and for anybody from outside can open this page directly. So it actually arises a lot of questions that how the integrity of the application works. I will show you and it will be more clear to you. Yeah, so what I will do is I will end this log clear and I will type a simple command adb shell. You can do it with many applications. I will do it with abd shell because it's lightweight. I don't have to use another application. And you can do it with many applications like Frida, like Droger, and all these applications also do this the same work. But I will use ADB because I don't want to install and introduce another application in this picture because then we have to explain that and it actually complicates. ADB will do 90% of the pen testing work for you. You will not need another application. If you're doing manual testing, automated testing actually is another topic. I will type start and uh, I will type in command N and I will type uh, wait the name the basically the packet name. It's a seam dot diva and apd it's a space API credentials. I think so. Credential don't have a gap in it. Yeah, so it's cred only. Cred activity. Yeah. So how it should work is I will click on it and it doesn't do anything. Wait, the intent failed actually. Okay, the intent actually failed. I don't know how it should. I'm writing the right command, right? Okay, sorry, it's creds. Mistake. Okay, it's still not working. Uh, yeah, now it worked. So I don't know if you saw it, how it happens. I think so. All the hassle actually uh, made me also skip the part. Okay, so this is the command you write to run an activity in the phone. So this will actually bypass the permission. AM will bypass the permission for you to make you a legitimate user. And start will actually like how it's works. Start N is for what you actually want to start. So N is for name. And when you type, what you actually have to type is the application's package name, that what we saw in the first part, and then this part, uh, the uh, activity that actually you want to start. So you will start it with dot API cred activity. And when you click on it, you see the second page actually opens. So when you see a second page actually getting opened, that means it actually bypassed the first page, and the second click of the application directly open it like this. Imagine this happening with a phone that have a login information in it. So if that phone actually opens the second page and doesn't get from the journey from the like the hierarchy of how every page should be open, like the first click and the second click and third click, something like this. Something like happening to this is a very big vulnerability. It actually stands on top three of the biggest mobile vulnerabilities, and uh, it's very simple that you don't intend to be false. Now I will talk about how manifest file works. So I will go on the same thing, and you can see in the same data there is a Android manifest XML. I will minimize this, maximize this for you to see the manifest file, and this will be the last thing that I will cover in this session. So as you can see, there are many activity providers, activity intent, activity, user permission, and stuff like this. So this actually is the core of any application. The permissions, the intent, the activity actually are listed here. If it's not going to be listed here, it will not work. So what we saw actually was that if the provider, and you can spot it very easily. Um, how you can spot it is the access control. How you can spot access control issues are whenever you go to like things like this, Android debuggable true. That means it's already been true for this application to be debuggable. It's also a good practice to make it debuggable, because not every application actually have a flaw in it. Sometimes it actually have to work properly, so the developers actually make changes by debugging it and filing reports for it. What is the important part here is what is the permissions here. So whenever you see something like this, Android exported true, that means that there is a permission that should not be, this should be false, but it's been listed as true, and we should not be there. So whenever you see something like this, you always have to put a red flag on it, and try to make, if you are actually trying to find vulnerabilities in it, you can use this information, and by using this information you actually can move forward with doing many more things. Uh, uh, Now I will just open up an application which can actually help you to do a lot of static vulnerability testing. I will not this. I will open up downloads, and then mobfs here. Mobfs. I think so. It's in the root folder. Yeah. So there's one application called mobfs, mobile security. You can see the full name here, Mobile Security Framework mobfs. It's basically a tool, open source tool, which you can actually help you understand and find vulnerabilities in your application very fast. So how it actually works is it's very simple. You open it like this, mobfs. I think so it will open up. Does it open up? Wait, it's a run file or a okay. It's a sash file, sorry. Uh we do have that. No file in such directory. Okay, that's strange. Oh, sorry. Is it actually running? It's not running. Okay, it's not running. Should do. It's not working right now. It's actually not working. But it's actually a very good application. You can just drag it. And you can just drag the information. You can drag the application to this basically this page, and you can just put it there, and it will recognize everything which is wrong with that application, and actually give you hints to how to actually secure those, and how can you hide in the security of it, and whichever the whichever I'll stop sharing. Um, yeah. So whichever vulnerabilities are present in the application, and after that you can just go to the file and try to exploit all those vulnerabilities, and just get in the way of it. You can find hardening step into it also. It's a very good application. It's also open source, free, uh, and you can use it for as many applications you want to use, and uh, that's it. At the end, I will just say Android application testing is actually very easy. If you want to try it, you can. There are many resources on the internet. You can just get started with it. Uh, and there are many application testing applications that are also there. So you can just take those applications and in consideration and start your testing journey right now. So I will end this presentation by my side. Thank you everyone for joining in and for staying here. You can contact me in my on my LinkedIn profile. I'm also listed on the Cleap website, so you can on the Cleap page, so you can also contact me from there also. Thank you.
Thank you, Nishant, for the wonderful session. And I guess this hands-on experience on Android pen testing will be useful to many. And thank you for taking your valuable time out and speaking at our conference.
Thank you.